This is an animation curve. It's a pretty cool tool in Unity which you can use to visualize your curves. You can also add a new key, adjust it to your liking. You can even change up like tangents, let's say linear. So pretty much shape it exactly the way you want, right? And a cool way we can make use of this, other than just animation, is actually for movement. So if we press play here, we have 3 objects which we can move, and they're all characterized by 3 different types of movement. So one's heavy, one's slippery, and what makes their movements all unique from each other is these curves here. So if we look at the heavy one, for example, you can see we can create an acceleration curve, a deceleration curve, and that makes up this timeline here. So as we can see, what tends to happen with moving heavy objects is it slowly, gradually speeds up, and then it suddenly, like when we stop, it suddenly just slows down. And then for slippery, it's like the opposite, where we quickly like pick up pace, and then we slow down quite slowly. And this can be pretty great for not just moving players, but also enemy movement and anything that has a motion pretty much, like vehicles, for example. And that's what we're going to be making today. So starting off with a new project in Unity, let's create a new script and name it Motion Curve. Let's open that up. And we want this to be a scriptable object. The reason why is because it'd be pretty useful to be able to plug and play, to be able to create the settings of our curves and add it and reuse them across the objects we want to move. So yep, and motion curve will be made up of 2 animation curves, so public animation curve, acceleration, and the one's going to be called deceleration. And just to make our lives easier, we're going to initialize them by default. So acceleration, we want a basic increasing curve, so equals to a new animation curve. We're going to take in 2 keyframes. So keyframe, the first one, we're going to start at time 0 with the value 0, and then finish at 1 with the value 1. It's going to go from low to high. For deceleration, it's going to be pretty much the same thing, but we are going to start at with value 0 and finish at value, start at 1 and finish at 0. Now we can add in our optional timeline curve. So animation curve, timeline. And to create our curve, we can use the onValidate function. So whenever we make changes to our 2 curves, we can update timeline. So firstly, let's reset timeline. So equals to a new animation curve. Now let's add in our acceleration. So we can simply loop through all the acceleration keys and add a timeline. So let's do a for each loop. Acceleration. So for every key in acceleration.keys, we're going to add it to timeline. So timeline.addKey. Now for deceleration, we want to simply add in all the keys, loop through all the keys, because we want to add an offset to them, so they will start after our acceleration curve. So let's create the offset. Float, let's call it deceleration start time. And so we want to start after the acceleration curve, so we want to get the last key, get the time of that last key. So acceleration at index, acceleration.length -1 .time. I want to add a bit more offset so we can create that line in between the 2 curves, the max speed line. So 0.5 for example. And because we need to add this offset to the deceleration keys before adding it to our timeline, we don't want to actually make changes to the deceleration curve. So we need to have a keyframe array, which we're going to make the changes to. So deceleration keys equals deceleration keys. Now we can make a for loop through all deceleration keys, so .length. Let's add the offset, so at index time, add the deceleration start time, before finally adding it to our timeline. So timeline.addKey, deceleration key index. Before I forget, because it's a scriptable object, let's create the asset menu for it. So file name equals to new motion curve, menu name equals to motion curve. Let's go back to Unity. Create a new motion curve. Let's name it movement curve. And yeah, as you can see, we can make an acceleration curve. Let's edit it a bit, and we can see here our timeline is being updated as well as we do. As you may notice, our timeline curve, this max speed line, it's not, when you want it to be straight, but it seems we want to make this tangent straight. So that's a quick fix. Let's go back to our script. Yes, so we want to fix that line, fix max speed line. We want to go to animation utility dot set key right tangent mode, and the key we're going to set the tangent mode of is the last acceleration key. So it's going to be in our timeline, and the index, so acceleration dot length -1. I'm going to set the tangent mode to be, so animation utility dot tangent mode be constant, and that should fix it. Back to Unity. And that seems to have fixed it. So now that we have our motion curve, we need a way to actually make use of these settings to control the speed of our moving object. So let's go to motion curve. And at the bottom, we're going to need a struct. So public struct motion controller. And now what this is essentially going to do is it's going to use the motion curve we assigned to it, and it's going to calculate a speed value which our moving object is going to access from the outside through this motion controller. So let's give it access to the motion curve. So serialize field motion curve, and we also need to know the top speed. So serialize field float speed max. And we are going to need to interpolate from 0 to our speed max. So we need a percent value here. Float speed percent. And using these two floats, we're going to output our result. So this is going to be accessed from the outside. Let's have a public property, public float speed, which is going to return speed max multiplied our speed percent. Now let's calculate our speed percent. So we're going to need a update function, which we're going to have to call from the outside. So public void update, and we're gonna need to know when our object is moving and when it's not. So we're gonna have to pass in like a boolean, like is moving. In the case of player movement, for example, that's when we're pressing directional keys. So we need to know whether we're moving or not, so we can either accelerate or decelerate our percent. So inside the function, let's have a animation curve. This is going to be our current curve, which is going to be equal to, if we are moving, then it's going to be the acceleration curve. So curve dot acceleration, otherwise deceleration curve. Now, before we calculate our speed percent, we need a time value. So let's define that outside the function, float time. And this is going to be increasing over time to go through our curve from 0 to the end. So let's add time.delta time, and don't forget to clamp it from 0 to the duration of the curve. So time then equals to math.clamp from 0 to the duration of our current curve. So current curve at index current curve -1 dot length -1. So we're getting the last keyframe dot time. And as you can see, we're going to be doing this a lot. We're going to be getting the duration of our curves a lot, of animation curves. Like for example, in the motion curve, we're doing it to calculate the deceleration start time. So what will be really handy, especially for the long term, is to have some sort of utility class, which we can extend from animation curves to call this. So let's go back to Unity. This is going to be a new script, so it's going to be called motion, actually, animation curve extensions. Let's open that up. Don't need to extend from mono behavior, and it's going to be static. So let's define that function. So let's say public static turning a float get duration, and yep, it's going to be this animation curve that we're extending from, and that's going to return us curve like normal, curve at the last index dot length minus 1 dot time. Now we can go back to motion curve and simplify some of this code. So here we could say in motion controller current curve dot get duration, take this out, and back in motion curve, when we're calculating the deceleration start time, you can get the acceleration duration by just calling the extension method get duration. Now that we have our time, back into our motion controller, we can finally calculate our speed percent. So speed percent is going to be calculated. So current curve dot evaluate at the time, the increasing time. So we're going to get our speed percent that way, and in return that will give us the speed. So we're going to be interpolating from 0 to our max speed with this percent value. And now one thing we're missing, the last thing, is that when we are transitioning between the two curves, so if we're accelerating and then we suddenly stop moving, the time isn't always going to be correct, because we want time to be where we would be getting the same value. So for example, if we go back to Unity, to this motion curve, this acceleration curve, if we stop halfway, we want to, and this gives us a value of, let's say, 10, we want to decelerate from 10. So if we stop here, 10, we need to find 10 and decelerate from that point. Otherwise, we're going to be jumping between values. So what we're going to do is we need to keep track of when we change our moving state. So we're going to have to define a bool from the outside. Bool was moving. And that way, here we can say if is moving is not equal to was moving, so we either suddenly stopped or started moving, then we want to make sure time is set to the correct point. So time is equal to current curve, and this is something we can't do yet. We need to be able to get a time by value rather than we've done here, which we're getting a value by time. So this is a good chance to add a new extension method. So back to animation curve extensions. Down here, we want a public static float get time method. So taking in this animation curve, we want to pass in float value. And now there's two ways to go about this. One way is doing it linearly. So we would be starting from 0 and slowly incrementing our time by small steps until we find a close enough value. But a much more efficient way of doing it would be the binary search algorithm. That way there's a lot less iterations. And the way this algorithm works is, I'll go through it. We're going to need a start time and an end time. So float start, it's going to be from 0, and of course our end time is going to be the duration of our curve. So we can actually call this extension method curve.getDuration. And now here comes the loop. So while start is smaller than or equal to end, we're going to keep going, and we should eventually find our time. So each iteration, we're going to have a time, so float time, and this is going to be in between our start and end time. So we're going to have to say start plus end and all that divided by 2. So essentially getting the midpoint here. Now we're going to have to see what value that gives us to see if it's close enough to our value, our target value. So float current value is equal to curve.evaluate at time. And so let's see if it's close enough. So we're going to get the absolute value of this distance. So math f.absolute of value minus current value. And if that's within some threshold, so we can define it up here. Let's say constant float max distance. By default, we can say something like 0.05. So if it's within that threshold, then this time is valid enough. So let's return that time. Otherwise, we're gonna have to keep going. And so if the current value we get is smaller than our target value, then that means we need to get a bigger value. So in order to do that, we're gonna have to shift our start time to the right so that next time we get our time, it's going to be bigger, and therefore closer to our target value. So we're going to say start is equal to time. So discarding everything on the left side of this start. Otherwise, it's going to be the opposite if our current value is actually greater than value. So we're going to be setting end to be time. So discarding everything at the right. And then it's going to go again, and we're going to get time. Eventually find our time, and it's very unlikely, but if we don't, let's just log an error. So log warning, time not found, and return -1 because we failed. And there's one more thing we're missing, and the thing is, this is assuming that our curve is accelerating, so we're starting from low to high, but we know that we're receiving decelerating curves as well, so we could be getting from high to low. So that makes the shifting of start and end completely wrong if we are decelerating in this case. So up here, let's have a boolean for that. So bool, whether we're accelerating, and we know the curve is accelerating if our first keyframe value is smaller than the last one. So curve at index 0 dot value is smaller than curve at index curve dot length minus 1 dot value. If that's the case, then this is still correct. Same with this one. And if it's not accelerating, there's going to be pretty much the opposite. So in the case of here, when current value is smaller than value, then the bigger values is at the left. So you want to shift end to the left. So end equals to time, and it's the opposite for here. Start equals to time. And now we are able to evaluate on our curves to get time by value. So let's go back to motion curve. Here we can make sure that time is this, like the speed percent we have is going to be the same with the curve we're transitioning into. So making sure of that with time. So time equals to current curve dot get time. So make sure the speed percent we get after transitioning is going to be as close as possible to the speed percent right now. Oh, and also make sure we are actually setting was moving, so we know that we're moving last frame. So at the end of the update function, just say was moving is equal to is moving. Yep, and that's pretty much it. So with motion controller, we can pass in any motion curve, so any settings, and it will do all the internal workings of
calculating the final speed value, which is what we ultimately want from this struct. So it will use the momentum we have in our motion curves. And just to see how, just an example of how this can work, we can use this. Let's make a simple player movement script. So let's go back to Unity. And let's create a new player movement script. Player movement. Open that up. Let's keep the update. And of course, let's have for this we want a motion controller. And let's call this movement controller. Because that's what the motion is. It's for the player movement. And in the update function, let's start off by getting the directional input. So it's equal to a new vector2. The x is going to be input.get axis raw horizontal, and y is going to be vertical. Axis raw vertical, and let's also know that whether we're moving or not. So let's have a boolean here is moving, and we'll know we're moving if directional input is not 0. So it's not equal to vector2.0. Down here, let's also make sure we're calling the update function in our movement controller, passing in the isMoving boolean. And now with all this, we can start moving. So let's create vector3 move direction equal to vector3.right multiplied by directional input.x plus vector3.forward multiplied by directional input.y. With that, we can have move velocity, which is equal to the move direction multiplied by the speed, which is calculated by our movement controller. So, dot speed. And with this, we can finally move our object to transform.translate by move velocity multiplied by time.delta time. And just one last thing I want to add, just to make sure, I want to make the direction smoother, otherwise it's going to be a bit too rough. So up here, we need a few variables. So we need our smooth direction, so direction no input smooth. And let's use this instead of directional input for our move direction, so swap that out. And we're going to be calculating this by using the smooth damp function. So down here, after we get our input, we can say the smooth directional input is equal to vector2.smoothDamp smooth. And for the target, we want to store this in a separate variable. So directional input smooth input target. And the reason for that is because we want to maintain the last direction they were moving in. So we can keep decelerating in that direction, because we don't want to stop too soon because our direction has been set to 0. So let's use that instead for our target. So we're going to only set this if we are moving. So target is equal to directional input. We need 2 more variables, so we need the current velocity, directional input velocity, and we also need a variable which we can tweak from the outside, float directional input smooth time. You could set this by default actually, something like 0.2 or 3. So let's put that in. So by reference, we want to put in the velocity and then the smooth time. And yeah, that should be pretty much it. Let's go back to Unity. Let's start creating a little scene here. Create a capsule, and let's drag in our player movement script. Oh, one thing I forgot to do. if we go back to motion curve, we need to make sure we're serializing the struct. So right above it, just say system.serializable. That way it can show up in the inspector. Back to Unity. Capsule. Let's name our capsule player. And there we go. Now we can see it. And let's actually create a new motion curve. So let's let it be slippery. Go into acceleration curve. Let's say we like this shape. And may want to progress a bit quicker, so something like 0.35. That's good. But we want to take quite a bit to actually stop. So let's drag out this time to something like 1.55. Look at our timeline. Pretty cool. And now in our player, we can drag in the slippery and set a speed max, something like 7. Okay, press play. Try moving it, and we can see we are smoothly moving around. Very nice. And yep, we can also tweak this while testing, so you can just go to slippery. Let's say we don't want it to take so long to slow down. Just change the time, something like 0.5. We can see the changes in real time. Very cool. But yeah, thank you for watching. All the useful links is in the description. And I'll see you guys next time. Bye!